Bonjour, alors cette vidéo devait être la semaine dernière, mais on va continuer cette semaine pour les réponses, la deuxième partie des réponses du Homework 1. On va parler du cisaillement, shear, shear out, tear out, tension, interaction, shear tension, bearing, qui est le bearing et transition bearing. On va parler du matage. Après le pin bending, on va pas parler du pin bending, c'est le cas de cale, et on va regarder la torsion d'une fixation. L'unfolding aussi, on va pas parler beaucoup, c'est le dépliage, c'est le cas si on va bouger le centre d'une fixation ou le centre d'un hole, d'un trou un peu plus loin ou un peu plus proche vers un rayon d'une plaque pliée, par exemple. L'inter-UV backlink, on a parlé déjà du phénomène, on va pas aller vers la formule, vers les formules mathématiques, mais ça diffère avec les spécificités de chaque programme qu'on travaille sur, que ce soit des aéronefs ou autres. Alors, et on va parler de la théorie de Hutt un peu. Alors on va commencer. So shear stress on a plate. At the physical point of view, this will define the shear stress, tau, which is exerted parallel to the surface of the plate. Definition: the force is applied to the structure area of the same plate as tau equal to force on divided by the area, the surface area. So we know that the margin of safety is the allowable, the material allowable on shear, the shear stress allowable divided by the applied shear stress. So this is the applied shear stress, which is tau, which is equal to the load divided by the load divided by the surface. Tension stress on a plate. In engineering, the tension on a plate is often analyzed as normal stress, resulting from forces applied parallel to its mean plane, or from bending. Definition: it's the internal tensile force per unit cross-sectional area. The basic formula is the stress is equal to the force, the applied force, divided by the surface. So shear and tension stress on a joint fasteners. We were checking the shear and tension tensile stresses on a plate, but what about on the fasteners that they are like the fasteners at the joint? Shear on a fastener is a transverse force acting perpendicular to the fastener's axis, attempting to cut or slice it across its trunk, similar to a pair of scissors. It causes the connected materials to slide in opposite directions, causing stress across the ball's cross-sectional area rather than along its length. So there is single shear and there is double shear. What's single shear? Involves one shear plane, two parts joined, like you see on the picture on the left at the above one, that one, and under it there we can see the double shear. While double shear involves two planes, three parts joined, which doubles the capacity. So failure mechanism and formula. The failure occurs when the fastener is sliced or broken by forces exceeding its material strength, often occurring at the thread-shank interface. The formula is the allowable shear of the fastener, shear fastener allowable capacity, usually defined with its technical aspects, divided by the applied shear load on the joint. So what shear here vs tension, while tension pulls the fastener apart along its axis, as you can see in the picture at the right hand. You can see the shear acts perpendicular to it, and you can see the tension loads. The tension pulls a fastener apart along its axis. The capacity factors are like shear strength depends on the bolt material, cross-sectional area, and threaded shank is stronger than threaded, and the plane of floating. Shear tension interaction on a joint. The shear tension interaction describes how the ability of a structural element like bolt, connector, adhesive to resist a shear force is reduced by the simultaneous presence of a tensile force, and vice versa. The interaction equation 1 divided by shear stress plus 1 divided by tensile stress equal 1 is simplified linear interaction, non-standard form, often used for approximating failure and a combined loading. So I'm not gonna talk so much about the bearing or tear out, as we already have some we had a little bit knowledge about it in when we were talking in the first part about the edge distance, because I already spoke about it. And so the bearing deformation and the tear out. The tear out, when we have that edge distance, the tear out is like shear, but it's shear out, like it's like it depends from the edge distance, not like the shear, and not like the simple shear, I mean. And the bearing deformation, I'm gonna talk about its formula more than the definition, because also I think we defined that on the part 1 as much as I remember. So in the edge distance part, so the bearing formula is allowable bearing stress of the plate, and it depends on the edge distance, that allowable. So it's the allowable bearing stress of the plate multiplied by the plate thickness and the fastener diameter. Like this, it becomes a load, and all divided by applied shear load. All divided by applied shear load. Like this, you can get the margin, the bearing margin. I'm not going to talk about transition bearing and other notions like folding that can, or interleaved buckling, which like can depend. It may depend from the page that we already spoke about it in the first part. In folding it may depend also from the tension force that is applied on the fastener, as like the center hold, the distance to jusqu'au rayon, je veux dire. We're gonna talk about Heth theory. We're gonna focus about Heth theory, and then we're gonna come back to the book of Mr. Neo. Like this, we're gonna not like lose much time on the other aspects, like there's diagonal tension and other phenomena. You may search for that, and if you are working on the on some industry, you may refer to the specificities. Each airplane or program have its specificities. Its specific. I don't find it in English. Les spécificités in French. Les spécificités de chaque programme. Like for ATR program is different from the A220 and different from the Airbus 320. Different the certification reports, like you need to check that. It depends from there are tools developed by engineers, and that's more like you have the basic aspects, like so health theory is like we're going to talk about fastener flexibility and joint flexibility in general can have a significant effect on how loads are carried in and transferred through a structure. Numerous methods exist to estimate fastener stiffness, la rigidité. Inspire has implemented the Huth-Schwarman method, but also allows you to specify an independently calculated stiffness. In an idealized infinitely stiffness connection as shown below, the amount of load transferred to the center rivet is 0%, with 50% on each of the outer rivets, like seen in the first picture in the both side. At the middle, if the connections are infinitely soft, then the load will be transferred equally between rivets, like 33%, 33%, 33%. And at the bottom, you can see for the real fasteners, the actual load carried will be somewhere between those limit values, like for example 30% on the center rivet and 35% on each the outer rivets. For connections to end between plates, as are often found in the aircraft industry, a popular way to approximate the fastener stiffness is by using the Huth-Schwarman method. This stiffness is calculating using the following formula, as you see in the screen. So where n equal to 1 for single shear and n equal to 2 for double shear, and a and b depends on the type of joint as per the following table, like you see the table below this one, and we come back to the formula. The following parameters also apply, like in the formula, D is the hole diameter, so Huth theory, like you see the table below this one, and we come back to the formula. The following parameters also apply, like in the formula, D is the hole diameter, T is the plate thickness, E is the Young's modulus of the material. We have the le ratio de Poisson, and this is like 1 and 2 are for the plate 1 and plate 2. That's the theory, and it's really needed to check the transfer load, and it's needed in the certification phase or while the concessions. It's really useful. Alors, je ne vais pas me lancer dans plus de détails, que ce soit pour les méthodes comme la méthode de Coson, ou pour expliquer plus de définitions des phénomènes, comme le phénomène de tension diagonale. Donc, je vais m'arrêter à ce stade pour continuer sur le livre. Donc, dans les prochaines vidéos, normalement, on va revenir sur le livre de Monsieur Niou. So that's all for homework 1 answers part 1 and part 2, and thank you for your attention. Thank you.